Okay, good afternoon. So I'm going to be talking today about the complex nature of variant interactions in cancer, really requiring updates to a lot of our variant interpretation resources. Sorry.
Yeah.
Oh.
There it goes.
It went. I have no relevant disclosures. I can't see my
Breaking
slides
our
anymore.
lightning
Okay.
talk.
Yeah, sorry.
rule here. I don't think
slides
it's a
disappeared.
button issue.
Well-
Can someone at the back advance the slides? There we go.
So I want to start by thanking the organizers for letting me discuss our work today. Civic is an open access knowledge base designed to support the clinical interpretation of variants in cancer. So it's both a knowledge base and a curation system, and this is a resource that's really easily accessed at civicdb.org. So Civic is about addressing this interpretation bottleneck, something that has been addressed a few times in previous talks today. And it's really about bringing that information together into a centralized resource that's readily accessible. So Civic is about turning information such as this, which is this Kaplan-Meier curve in a peer-reviewed published literature showing the difference between survival of patients with and without specific variants, and turning it into what you see at the bottom here, this evidence item that has both human-readable text but also structured elements that allow the reader to quickly identify what's going on, but also puts in words what the picture tells you rather quickly. And so it stores these words in a very structured manner, and then it's easily searchable for anybody that comes to the website. And we call these structured evidence pieces evidence items, and they're all associated with the peer-reviewed published literature. So this does not include PHI that Dr. Klein was talking about. But this is still a really important part of this process. So back in April, we actually launched a new version of Civic that has really updated the user interface, the API, and also the data model. And some of these big changes were really necessary for us to expand on the existing data model and create more complex interactions. And so we've got more features that are coming, but I'm going to focus on molecular profiles today. So molecular profiles allow you to associate multiple variants using Boolean terms. So you can use and or not to create relationships between variants. And while we often think about variants as, oh, this variant, we all know that this is becoming more and more prevalent, the interaction between these variants as being important. As some great examples in the WHO diagnostic criteria for lymphomas, you can see that there's an and relationship between MYC rearrangements and BCL2 rearrangements. And in the case of risk stratification for acute myeloid leukemia, you have different interactions between the mutation status of NPM1 and FLT3. And so we can put these variants together, keeping each of them as modular structured data, but then associate them with using these Boolean operators. We can associate specific pieces of evidence to these individual variants, but then we can also associate evidence with this collection of variants. And this is what we're calling a molecular profile. And this allows us to capture this evidence in a more structured, more specific way. So when these are soon to be live, we'll be able to just see them on the left side of the website, and then you can actually look and see this particular molecular profile, so NPM1 exon 12 mutation and not FLT3-ITD, also has next to it another alias, which is the more common way that is specifically stated in the ELN risk criteria. But when you click on that molecular profile, you start to get more details about it. So we can actually put a structured summary that is curated information, again, human readable, and so you can put more details into this there. But you can also add things like aliases that make this much easier to search in common sort of nomenclature. For example, the lymphoma example that I showed, a double hit lymphoma. We can call it that, or we can call it by the specific variants that are composing that molecular profile. But the other thing about this is you can really quickly see the underlying, and I know it's quite small, but you can see the underlying variants that are associated with this. And so in the purple boxes, you can see NPM1 and you can see FLT3 ITD, and you can navigate to those immediately, but you can also see more details about those variants, including summaries. And at the bottom, you can see all the evidence that's specifically related to this molecular profile. So in summary, and I'm talking very fast, but as clinical guidelines involve these more complex relationships, we really need knowledge bases to kind of keep up. It can't just be thinking about one variant in a single instance. So CIVIC, this 2.0, really redesigned how we put this data model together to allow for these more complex relationships. And molecular profiles are going to provide support for these more complex relationships, but also make them easy to find and navigate within the user interface. And at the bottom here, we've got a quick GIF that is just showing how easy it is to find variants and then create these relationships within the user interface. So with that, I do want to emphasize that if you have any help or any questions, or would you like any help or have any questions about the CIVIC knowledge base, you can always let us know at help@civicdb.org. And with that, I want to acknowledge the CIVIC community. A lot of folks in this audience are part of that, but also the Griffith Lab, from which a lot of this work is derived, and then of course our funding sources as well.